The homework for Lesson 6 on Raspberry Pi Pico, provided by Paul McWhorter, covers devices that he covered in previous lessons. In this lesson, we will be using LEDs and a variable resistor called a potentiometer. Here in this shot, we can see we have 3 LEDs installed. The red, yellow, and green. Each one is attached to the positive side to the GPIO pins 15, 14, and 13 respectively. We also have a 3.3 volt source attached to the positive rail of this breadboard, and the ground attached to the negative rail of the breadboard. As far as the LEDs are concerned, the negative side is connected to that railing by way of these current limiting resistors. The potentiometer has 3 pins. One pin is connected to ground. Another pin is connected to the 3.3 volt rail, and the center pin is connected to the analog digital converter on the Raspberry Pi Pico. It will vary depending on how you turn this rotary dial on the potentiometer. The analog to digital converter on the Pico can give values from 0 to 65,535. This is the code being used to implement the homework assignment. The purpose is to have the potentiometer act as though it's representing the load on a motor. So to accomplish that, we import a couple libraries. We assign the red, yellow, and green LEDs to pins 15, 14, and 13 respectively, and have them all indicated as outputs. The potentiometer is connected to GPIO pin 28. Then we assign that to the library and call that my pin. Now what we want to do is have the load represent a value from 0 to 100, or a percentage. Now one problem is that if you set the potentiometer to its minimum value, you don't always get 0. There's a lot of noise and it fluctuates. You have to sort of guess where the lowest number is. In this case, it looks like it's about 260. Now above that, the maximum Y values are from 0 to 100 on the XY axis. The minimum X value in this case is 260, and the maximum is the 65,535. I start out by setting the max value as the potentiometer value is half of the max, but that will change pretty quickly as soon as we hook up the potentiometer. So in this while loop, first thing we do is to read the A to C, analog to digital converter value that's coming in from the potentiometer. And then from that, we calculate the load. And this is the calculation to arrive at that value. You should end up with a value of 0 to 100. Now, the way the assignment was given, if the load is below 80, we want to light the green light and not light the yellow and red. If it's from 80 up to but not including 95, we turn on the yellow light. And if it's at 95 or greater, it's like an alarm situation. It's under a heavy load. We turn off the green, yellow, and turn on the red. We delay for a half a second and do this over again. So this is in a continuous loop over and over again until something aborts the lesson. Now we'll show a video of the program in action. You see we're starting out and the setting is pretty close to the threshold. But even there, the yellow light is on. If I adjust the potentiometer, in this case, it's being turned up, and you'll see when we get up to the 95 or above, the red LED is on. And then as we start lowering it, then the yellow LED comes on when it's below 95. And then if we keep turning it, well, let's okay, we're right at the threshold there. Now we're below the 95. Turn it more, and we get down to the threshold at 80, and you see when it's below 80, the green LED comes on. We may be able to get a point where it's right at the threshold, and you'll see it bounce back and forth between two LEDs. Oh, in this case, we've gone down as low as we can go. You notice at zero, because of noise, it bounces around. And then when we get up, well, let's see, it's being turned back up toward the threshold of the moderate load again. It's hard to get that adjusted just right on the threshold. Now you can see it's at the threshold, and it's bouncing back and forth between green and yellow as those numbers fluctuate. That's because of noise in the system.